We learned in past weeks that the ocean currents can affect temperature. It can affect the way that our weather happens for us. There are warm water currents, there are cool water currents, and currents stay the same in the oceans. If you look at the map on the right hand side, you're going to see arrows, and those arrows, they don't change. Now, because of global warming, those patterns, or those air the water flow is slowing down, but the pattern or the direction and where they flow, that stays the same all the time. And because of those weather currents, we get different types of weather. We just talked about hurricanes a week or two ago, and we know that hurricanes, they start near the equator, and then they flow in the same pattern. So for example, hurricanes start in the equator and they head towards the Gulf of Mexico. And the Gulf of Mexico is this body of water right down here on the southern end of the United States. Many times hurricanes go right there. Why do they always go in the same place? Because hurricanes frequently originate right here, and then that, because of that water current, they're always going to flow this way. They're always going to flow right into the Gulf of Mexico, and then they typically head up the east coast of the United States and circle back around. And that's why you're going to see these patterns of hurricanes. Um, Cool water, or on the other hand, so that's warm water because it originates near the equator. Cool water lowers the humidity. So if you look over on the west coast of the United States, you're going to see this cool water flow. And that goes right down the western coast, down Washington and Oregon and California. And that water also circles. You're going to hear about things like whale migration, or people going to do whale watching off the coasts. They have to go over here to do whale watching because the whales are migrating out of the cold waters near Alaska and heading to a little bit of warmer waters. And they swim the same route. They swim the same route every year to get to warm waters. You're not going to randomly see a whale over here necessarily, because they don't follow in the same water water patterns or water currents. It's not just ocean currents that can affect what kind of climate we have. The shape of the continent itself can affect what kind of climate we have. And this is now on the other side of the world. This is Asia and Europe and Africa and Australia. But this country right here is India. And India's shape, it's kind of a unique shape in that it's got water on both sides here, and it's near the equator. And that shape alone gives it its own special climate. And we're going to watch a video about that.
I am in the coastal state where the monsoon first arrives in India, Kerala. The key to understanding the monsoon is here on the beach.
Yes,
The monsoon
I'm
is
watching with
powered
you,
by a
so I can
simple
see
but
you watching.
incredibly significant difference. The difference between land and sea. And in particular, the differing ways in which they respond to the sun.
Take the sand as an example. The sun's energy is heating all of this surface, but if I dig down just a little way, the sand underneath here is quite cool, and that's quite familiar. We see that on sunny beaches all the time. And here, where it gets really hot, the surface can reach 40 degrees Celsius. Just 15 centimetres down into the sand, it could be only 7 degrees Celsius. So all of the sun's energy is going into a really thin surface layer, and that layer heats up really, really quickly. The sun is also beating down on the ocean, and that responds very, very differently. This energy at home, but it's much cooler than the beach. And the reason for that is that the ocean takes much more of the sun's energy to heat it up. So a kilogram of water will take 3 times as much energy as a kilogram of sand to heat by 1 degree. The ocean is also relatively cool because to heat the surface you have to heat much more than just a thin layer. What happens is that winds that blow across the surface of the ocean generate turbulence which mixes that top layer. So as soon as some water's been heated at the top, it gets mixed down below.
This means that unlike the land, the ocean warms up only very slowly as the sun's energy is absorbed. So as we enter summer, the land heats up quickly while the ocean lags further and further behind. This increasing temperature difference is critical because both land and sea heat the air above them. As the
Do you
sun
have
has
beverages or
baked
anything
the
in class?
the land has warmed the air above it. The warmer air is less dense, so it rises. This draws in the cooler air from the ocean. Because of India's particular geography, this process is magnified. It's a triangular peninsula with wide, hot plains and, crucially, a very long coastline. This combination sets up a powerful and sustained movement of cooler ocean air, the monsoon wind.
Of course, when most of us think of a monsoon, we think not of seasonal winds, but of rain. By setting up a time-lapse camera, I'm hoping to watch the rain clouds forming. Enormous process on the go here. When the sun shines down on the ocean surface, some of the water at the surface will evaporate, so water and energy are carried up into the atmosphere. And as the monsoon winds come inland and they carry that water vapour with them, the heated land makes that moist air rise, goes up into the clouds, and there droplets condense, the water condenses out, becomes visible, we see clouds, and when those droplets join together to form droplets that are large enough, we get rain like this, and it's really raining fast now. So what we're seeing now is a thin layer of the ocean that's been lifted up, shifted over here, and is now being dumped on top of me. None of this would be happening if it wasn't for the tilt of the earth. So the seasonal heating is what widens the gap in temperature between the land and the sea. And this drives everything, and this massive system of rain and wind rushes inland, and that's the monsoon.
80% of all India's rains arrive in this seasonal deluge. It's not just the volume of the monsoon rains which is impressive, it's the distance they travel. As summer progresses in India, the difference in temperature between land and ocean actually increases. This makes the whole monsoon system more powerful, drawing this moisture-laden air further and further inland. From when the monsoon first arrives on the Kerala coast around June the 1st, it spreads more than 2,000 kilometres until it eventually reaches the far north of the country.
Okay, what I would like you to do on the last slide in this presentation is I want you to write down 3 things that you picked up either from this video or from the first 2 slides in this presentation. So for your assignment today, I would like you to write down 3 things that you picked up about climate and how the land can affect the climate. I gave you a lot of them that you could write down right here. So if you want to go back and watch my video again, you'll see a lot of the answers right here.